Hi, my name's Caden Smith,
And I'm Ryan Asefi.
and this is our Crime in Georgia final project for CS 2316.
For our project, we decided to focus on crime in Georgia, the state we live in. So, for every 100,000 people in Georgia, 427 of them are incarcerated, whereas the national average is 307. And we wanted to focus on the basics about crime, such as crime rate and population, demographics, education.
We ended up finding three data sets. The first was our downloaded data set, the challenge full data set, which was about individuals and their specific crimes. It's about 26,000 rows. Our second data set comes from a table in the HTML file from the FBI's 2018 crime statistics on the state of Georgia. Our last data set was a JSON file from Corgi's state crime data, which included data on all 50 states, but we just used each of the 70 dictionaries from the years pertaining to Georgia.
For phase two, we began cleaning our three data sets in preparation for phase three. And some of the inconsistencies we found were the not a number values in the CSV files, along with inconsistent data types. And another one was like the ages columns that we had to change. And there also was the missing arson data file.
This first data set was our challenge data set from the CSV file. It has a massive number of columns, as you can see, and an even larger number of rows. It was our main data set in this experiment. In order to clean this data and put it in a data frame, we first imported CSV and pandas and filtered the columns. We renamed these columns to more appropriate values for this experiment and fixed the H data inconsistency first. Our in-gang column had NA values, so we used a dot fill in a method to add question marks to those spots. We added a numeric education column as well as created consistent data types in our other columns before displaying the data. Our resulting data frame looked like this in Jupyter Notebook and looked like this in our new CSV file, which we named clean_challenge.
This is the 2018 FBI crime data set, and it lists various crimes committed in the state of Georgia.
In order to gather this data, we used Beautiful Soup as our chosen HTML parser. We parsed the data using .find and .findAll methods we learned in class and built a data frame from it. We initialized an empty list and built it row by row and then eventually created a data frame from it. We then renamed many of the columns in this data frame and fixed the inconsistencies such as the arson inconsistencies within, and then finally displayed our data by converting the data frame to a CSV file and returning the actual data frame.
After cleaning, this was the resulting data frame from the code. Then we exported our data to a CSV file, as shown.
Our third and final dataset was a JSON file that looked like this. Each dictionary is for a particular state and a particular year. We just used all of the dictionaries from the years 1960 to 2019 with the state label Georgia. In order to clean this data, we first unpacked it using a .load method. We then used a method we didn't learn in class called .get to use a list iteration to filter for only the Georgia data. From this, we were able to extract only the data from the dictionaries that we wanted and build the resulting data frame. We then exported this to a CSV file. Our resulting data frame with the years as the indexes is shown here. Our exported CSV file called yearly data is shown here, with the rates of each crime rate in its data points.
Phase three is where the project started getting interesting. We started to clean our data and we gathered insights into perpetrators, demographics, and how population influenced crime and much more. Also, whenever we were gathering these insights, we created visual representations of each of them, which was to show the data and illustrate the trends we found.
Insight 1 answered the following question: are the number of misdemeanors and felonies committed by given criminals connected? By importing our now clean challenge dataset, we were able to group by the number of felonies each perpetrator had committed and aggregate the number of misdemeanors they had also committed. The results are shown in the data frame on the right. In order to better see this data, we used a matplotlib style bar chart. As you can see, as the number of felonies on the x-axis increases, the general trend is that the number of misdemeanors on the y-axis increases. We also included error bars on this graph to show that this does vary a lot by individual.
In phase 2, we answered the question if gender and education level are usable statistics when predicting the future misdemeanors and felonies.
To answer this question, we first imported the data and grouped by gender and education, aggregating the number of misdemeanors and felonies in the challenge dataset. We then merged the data frames we had created and calculated percentages using the code shown here and dropped unnecessary columns.
Our results are shown in the data frame in the bottom right. To better illustrate this, we made 4 separate pie charts. As it turns out, education level had a larger effect on crimes committed than gender, but this effect was lessened in a woman than in men. It was also evident that the data did not need to be separated on crime type, as the data turned out to be almost identical for misdemeanors and felonies.
Are population and violent crime rates connected? Obviously, as population increases, the amount of crime increases, but does the actual rate stay the same? In order to answer this question, we imported our FBI crime data and calculated the rate per 1,000 people in each city for violent crime. We then sorted this data by population to make it easier to see in the data frame on the top right of the screen. During this process, we had to fix a missed inconsistency in data type. We continued our use of matplotlib to create the following scatter charts. They're both the exact same scatter chart, except the red subtracts the 10 largest outliers in population in order to better see the more dense data on the left-hand side. When you weight these data points based on the population, it becomes clear that as population rises, crime rate actually increases as well.
For Insight 4, we answered the question if the type of crime committed had any correlation to gang affiliation.
To answer this question, we imported our clean challenge data set and organized by gang affiliation, creating 2 separate data frames. We counted the total in-gang crimes and the total not in-gang crimes and separated it based on misdemeanors and felonies. We then combined these data frames into the one shown on the bottom right-hand side and created a percentage marker to make it clearer on.
As you can see in the pie charts, we determined that gang affiliation does connect to a higher rate of felonies being committed in comparison to misdemeanors.
For Insight 5, we answered the question, how have crime rates changed in Georgia over the past 70 years? We imported our data from our CSV file that we created yearly data with the index column year and calculated the average change per year by subtracting the original crime rate from the final crime rate in 2019. The resulting values are shown in the Panda series in the top right. In order to better communicate this data, we then created another bar chart. We followed the same steps as we used in the past to create a bar chart, but excluded population because its number was so much different than the crime rate data that it would have skewed the bar chart and made everything else look negligible by comparison. Consistent with our findings in Insight 3, we ultimately learned that most crime rates did increase, but not all of them. Despite the increase in population, the rates of burglaries and murders actually lowered, going against the overall trend of increasing crime rates over time. Hopefully the rest can follow suit in the future. Overall, this project had 5 main insights which led to 5 primary conclusions. First, a moderate correlation exists between the number of felonies committed and the number of misdemeanors committed for individuals, but there's a high deviation. Secondly, if committing a crime was a given, education level has a little effect on which type of crime is committed. College-educated women are more similar to the average woman in terms of crimes committed than their male counterparts. As population increases, overall violent crime rate increases. This isn't trivial because population increase is already accounted for in the rate calculation. Fourth, those in gangs are more likely to commit felonies as opposed to misdemeanors than those not in gangs. Finally, most crime rates have increased in Georgia since 1960 with some exceptions, murder and burglary. Using this data, we can make better estimations on who is most likely to commit certain crimes, and it can be used to predict future crime rates based on a variety of factors.
In this project, we learned many things that we had not previously discussed in class, some of these including looping through functions multiple times, fixing inconsistencies, handling datasets that were too large to trace manually, and how to use results from previous code to code in new code.
Some undiscussed techniques that we used as well were the .get method, adding error bars to a bar chart, using ticks to better show data in our visualizations, and fixing null and non-values at the same time, especially those which cannot be seen.